Hello everyone. In today's video, let's learn about 4 to 1 multiplexer. By the end of this video, you'll know how to draw the symbol for it, how to derive the Boolean expression, and how to design the circuit for 4 to 1 multiplexer. So let's get started. As we know, all MUXes has one output. So 4 to 1 MUX has 4 inputs and one output. So those are the input lines. Let's call them I0, I1, I2, and I3. And then we have one output. Let's call it Z. So how many selector lines we need for 4 to 1 MUX? And this is 4 by 1 MUX. So let I be the number of inputs and N be the number of select lines. So as we saw in the previous videos that I is equal to the power N, and we already said N is a number of select lines. So we know I is 4, we have 4 inputs. So this will give us 4 equal to the power N. So to make this equal, we know that N has to be equal to 2. So now for 4 to 1 MUX, we have 2 select lines. So let's call them A and B. So now this is the symbol for 4 to 1 MUX. So next, let's obtain the truth table for it. So we have 2 select lines A and B, and we have the output Z. So for A, B, we have 4 possible combinations, 0, 0, 0, 1, 1, 0, and 1, 1. When A and B are 0, 0, we will pass I0 to the output. So this will be I0. Similarly, when A, B are 0, 1, we will pass I1 to the output. So we'll have here I1. For 1, 0, we'll pass I2 to the output. For 1, 1, we will pass I3 to the output. Now from this table, we can write the Boolean expression. So Z is equal to, for the first row, A is 0 and B is 0. So we can write them as A bar, B bar, I0 plus. From the second row, A is 0 and B is 1. So we can write them A bar, B multiplied by I1 plus. The third row, A is 1. So this is A, B is 0. So B bar multiplied by I2 plus. Lastly, the last row, A is 1 and B is 1. So we'll have A multiplied by B multiplied by I3. So now simply you can take this Boolean expression and design the circuit for 4 to 1 MUX. So first we need, because we have summation, so we need an OR gate at the output. So this is an OR gate, and the output is Z. And then we have 4 terms, 1, 2, 3, and 4. So that means we need 4 AND gates to produce each term. So this is the first AND gate. And let's just create copies of this. So that's it. So the output of each of this AND gate is an input to this OR gate. So for the first AND gate, we want to make this term here. So one of the inputs is I0. So this is I0. And we need A bar multiplied by B bar. So let's have 2 inputs, A. So this is A. And then let's feed it also to a NOT gate to make A bar. And similarly, let's have another input B. And also let's use a NOT gate to get B bar. So now for the first AND gate, we need A bar and B bar. So we can take A bar from here and B bar from here. For the second term, we have I1 is one of the inputs. This is I1. And then we need A bar multiplied by B. So similarly, you can take A bar from here. And we need B, so we can take B from here. Now for this AND gate, we need to make this term I2. And we need A multiplied by B bar, so we can take A from here and B bar from here. And the last term, we need AB multiplied by I3, so this is I3. And we need A and B. So this is A and this is B. So this is the internal circuit of 4 to 1 MUX. I hope this was helpful. Thanks for watching.
Enjoyed this video? Subscribe to the Computer Engineering Notebook for more tutorials on computer architecture, embedded systems, and hardware design. And hit the bell to catch the next one.